We're hopeful that by the end of the year, we will see a mining permit in our hands. Yeah, thank you, Jack. It's a pleasure to be here today and appreciate the opportunity to talk a little bit about our project and our company vision going forward. The project that we have is located about 40 kilometers east of downtown Winnipeg, so it's not remote. It has lots of great infrastructure around it. It's a large deposit. We're showing about 15 billion tons of sand in situ. Um, for a recovery rate and for an SK 1300 or 43101 resource report, we use less than a 5% recovery, and so we show about 540 million tons of recoverable quartz sand material, albeit if I need more, which I doubt I would, but adding 1% recovery, brings me another 100 million tons. We were surprised to see that generally in mining and ore bodies, you see variability in grade, in purity, size distribution. We don't see that in our deposit. Um, the deposit is about 150 feet below surface. It's sitting in a freshwater aquifer, which is a benefit and a hurdle. In that the benefit is it's spent the last 500 million years being washed and turned over like a washing machine. And because of that, the deposit is very homogeneous. And so we're seeing similar grades, similar size distribution throughout the deposit. Of course, the challenge is that because it's in a freshwater aquifer, anytime you talk about drinking water, it becomes an emotionally charged conversation. And that's some of the issues that we've had regarding our permitting process. But we've developed a very environmentally friendly way to extract using just borehole airlift technology. And we believe when we are in operation, we'll be one of the most environmentally friendly mining operations worldwide, regardless of commodity. Our plan on what we want to do with this high purity silica is not only extract it and supply it for users through North America, but vertically integrate. And the reason being is, and I'm sure we'll get into that conversation today, but for silica to go to a semiconductor or a solar panel, it first goes through a variety of steps and it gets moved into generally some form of silicon, silicon carbide, a polysilica, silicon metal. There's a lot of opportunities for Canada and for Brazil to get involved in that advanced manufacturing process, at which, in my opinion, has really been given China its dominance over not only this commodity, but all of other commodities because of their investments into advanced manufacturing. And I think that's our intent with our project is to get involved with that, vertically integrate, and start using that material here closer to home. Yeah, I think, from our side, CO's been around now for 9 years.
Hmm.
Um, all of our offtake agreements right now for our product is with semiconductor companies in the US. We've gone through a variety of testing with them to show that the product can meet the specifications for what they need. It's not surprising to me that the US has moved towards that. I think bringing in back some dominance and some independency from China is important for all countries around the world. Um, what we have seen happening in the US is that although there's a lot of capital flowing and a lot of projects starting to be initiated in semiconductors and solar and AI, it is still a real battle for the raw materials and where that raw material is coming from. And as we touched about before, it's also where the initial advanced manufacturing or even beneficiation is going to happen. And as an example, one of the companies we have offtake agreements with, very similar to what happens at Spruce Pine in North Carolina, will go into the US and then into Malaysia to be beneficiated, and then back into the US to eventually end up with a semiconductor. And that's why my comment earlier is there's opportunities here for both Canadian and US businesses to get involved with things like that. We can beneficate that material here in North America and go straight from a raw material to a final product. You know what? There's been, from our experience, there's been a variety of incoming calls, both from overseas as well as
Hmm.
here within North America. Um, you know, as an example, there's a new technology being developed by the U.S. Air Force on some of their wingtip designs that use high purity silica, and so and they very quickly realize that where are we going to access this raw material? Is there enough availability of this material before we go too far down the road? So we've had a variety of incoming calls from groups like that, and other groups overseas in regards to just security of long-term raw materials.
Right.
Yeah, from CEO's perspective, we're going through our final permitting phase with the Manitoba government. We're hopeful that by the end of the year, we will see a mining permit in our hands. We are in a unique position in that, rare to us development and mining companies, we're actually fully funded for production already. So all the capital we need to build and initiate the mining operation is already accessible, pending a permit. The uniqueness of the product not having, it's not an open pit. There's no strip ratio there's no preparatory work that we have to do to get into the main area. So, we drill a simple 12-inch water well hole and we're producing in a matter of 2 or 3 days. So we can go from permit in hand to operations within 12 months. There's no anticipated delays because of financing. We have offtake agreements already in place with the semiconductor industry in the US. And so, we anticipate being cash flow positive within, 12 to 14 months from when we get the permit and break ground. We do. We've talked to and we're now partnered with a large solar panel or solar manufacturing engineering firm out of Germany. Um, this company, I think the largest outside of China. They've done about 60 gigawatts of production worldwide. They've got about 26 operations, or they're working in 26 different countries, building solar panel manufacturing facilities. Um, when I originally started speaking to them, we were thinking about vertical integration towards parts of the solar panel manufacturing. So, for example, creating the polysilica for it. What we eventually looked at, and very similar to Brian's comments about economics and pricing, you know, the the production of a solar panel requires a lot of energy because you are taking that silica to a polysilica, a silicon metal. Um, they want to create solar panel facilities that are ESG friendly. And so the input of electricity or whatever power is being used is very important to them. And when we started looking at Manitoba, we saw that Manitoba has a clean, renewable energy hydro source. It also has one of the lowest power rates in North America. And in the engineering work that these guys did, and this company is called RCT Solutions, and they have RCT Power as well. As Brian said, the power on the battery side is very important to the solar industry. Um, at the end of the day, they have come in and said, we believe we can produce a solar panel in Manitoba for the same landed cost as a Chinese panel. And that's the first time that he's been able to say that. And he is being enticed by the US government to come into the US side because of the market's growth in solar industry and also Brazil, because they see a large growth in Brazil as well. So our intentions is to look at working with this group to create a solar panel manufacturing facility from the ground up right into the panel in Manitoba. Well, and I think also to add to that is, less than 1%, and maybe even quite a bit less than that, of silica deposits in the world wide can meet this type of quality. And so
Hmm.
the scarcity of the raw material that's needed for solar, for battery, for semiconductors is really going to go into, a supply issue, and companies are seeing that around the world. And so there's no need to compete. There is enough of a market out there for all of us, and really we can work together because if we can make our products cleaner, better, more cost efficiently, it helps all of us. Well, you're correct. I mean, it's the same thing you said at the start of this. I didn't realize that the two of you guys were out there until
Right.
recently. So it's getting that awareness out, because it is such a scarce community, that commodity. Even to get them to believe you that the product is that pure, it is that clean, is a process that takes a little bit of time. And
Hmm.
for us, we're lucky in that. We bring our sand up at 99.86 in raw material. We take it to a 3N or a 99.9 with a simple water wash. We can take it now to a 5 and now into a 6N product at 99.999. And I think what a lot of people don't really understand is that every time you add a 9, it's exponential in its value, in the way it's used, albeit the amount of volume required is less because it goes into higher end products. But from a value chain, it is exponential. And so the availability and of an high purity silica, combine that with what's happening in the US, as Brian talked about, the innovation, the research and development. People are starting to be better and more efficient at their battery technology, their solar technology, their AI technology. But as a result of that, they need higher purity, cleaner silica, and they need the impurities out of it. And so even though you're at 99.999, if it's got 2 parts per million boron, some industries can't use it.
Oh,
So
absolutely not.
you really need to understand your impurities as well.
Hmm.
And I think from our perspective, although we're sitting right next door to, one of the largest markets in the US, we're hopeful that national or globally, everyone will see that there is a high purity product that people will demand worldwide, that they'll come to Manitoba to seek it out. Thanks.
Thanks, Jack. Appreciate your time. Faisal, great to meet you.
Yeah, likewise, Brian. Thank you. And thanks, Jack. And thanks to the CMI group to put this thing together.